Every single day, whether you're logging into an app, opening a file, or just browsing online, there are these two invisible guards constantly at work. They're checking you out, and they're asking two really simple questions. Who are you? And, okay, what are you allowed to do here? We call them authentication and authorization. Now, they sound kind of similar, but figuring out the difference is absolutely key to understanding how our entire digital world stays secure. So, let's break it down.
Probably the best way to get this is with the airport test. It's a perfect analogy. So think about it. When you go through security, you pull out your ID, right? That's authentication. You're just proving who you are. But then when you get to the gate, you show your boarding pass, and that's authorization. You're proving what you're allowed to do. In this case, get on this specific plane. See? One guard checks your identity. The other one checks your permissions.
So here's what we're going to cover. First, we'll nail down those definitions. Then we'll put authentication and authorization head to head. We'll look at the tech that makes it all work, stuff like OAuth and OIDC. We'll see how it's used in the real world. And finally, we'll check out a couple of different ways systems actually decide who gets to do what. Okay, so let's dive right in and get our definitions straight. It all kicks off with that first fundamental question every secure system has to ask. Are you really who you say you are? First up is authentication, and this is all about identity. It's the system literally challenging you, saying, prove it. Prove to me you are who you claim to be. This is where you type in your password, use your fingerprint, get that text message code, or answer a security question. It's the front door. It is always the first check. So, once the system knows who you are, the next question is, all right, you're in, but what are you allowed to do? And that is authorization. And notice, it always happens after you've been successfully authenticated. It's the process of checking a big list of rules and policies to figure out your permissions. So you're logged in, but can you actually see this file? Can you edit this document? Can you, access the admin settings? That's authorization.
Honestly, putting them side by side like this makes the difference totally crystal clear.
Yeah, this table just lays it all out, doesn't it? Authentication is about your identity. Authorization is about your permissions. Authentication challenges you for a password. Authorization checks you against a policy. And the order is so crucial. You authenticate first, then you get authorized. And that last row, that gives us a little peek under the hood. It's hinting that they even use different kinds of digital tokens to get their jobs done. And we're going to get to that right now. So, how does all this work in the real world? Well, under the hood, there are two key protocols running the show, OAuth 2.0 and OpenID Connect, or as you'll see it, OIDC. Let's start with OAuth 2.0. I guarantee you have seen this a million times. It's that little pop-up where one app asks, hey, can we have permission to access your contacts? Or can we post to your social media feed? OAuth 2.0 is the industry standard for delegating access. It's all about authorization. But here's the catch. Here's the crucial point. OAuth 2.0 is amazing at granting permissions, but it was never actually designed to figure out who the user is. It handles the what you can do part perfectly, but it leaves this big, glaring gap on the who you are side of things. And that is where OpenID Connect, or OIDC, swoops in to save the day. It's basically a thin layer that was built directly on top of OAuth 2.0, specifically to fill that identity gap. OIDC is what handles the authentication, the identity part, and then it just uses the normal OAuth 2.0 flow to securely pass that identity info along. This slide really shows their partnership perfectly. OIDC is for authentication, OAuth 2.0 is for authorization. They're a team. OIDC is built on top of OAuth, extending its capabilities. The best example? When you see login with Google, that's OIDC proving who you are. But when an app asks to access your Facebook photos, that's OAuth granting permission. They work hand in hand. Okay, so we've got these two protocols, OIDC for the who and OAuth for the what. But how do modern applications, which are often built from tons of tiny independent microservices, how do they actually put these to work? Let's check out a few common design patterns. So the first pattern is to have a single central bouncer at the front door. We call this an API gateway. It sits in front of all the other services, and it inspects every single incoming request. The huge advantage here is just simplicity and control. All of your security logic lives in one place, which is nice and tidy. The individual services in the back, they don't have to worry about authentication at all. They just trust that any request that actually makes it to them has already been vetted by that main gatekeeper.
All right, the second pattern is way more decentralized. In this model, the user gets a kind of digital hall pass, a secure token from an identity provider. Then they just show that pass to each individual service they want to access. Now, the beauty of this pattern is how incredibly scalable it is. Each service can check the pass all on its own without having to phone home to some central server. These digital passes are usually called JWTs or JSON Web Tokens. You can think of a JWT like a secure, tamper-proof envelope. Inside it has everything needed to know who you are and what you're allowed to do. This makes the whole system super fast and efficient. And a third pattern, one that's really common in big companies, is to use a dedicated central command post for all things security. This is known as an Identity and Access Management, or IAM system. With this setup, every single time a microservice needs to make a security decision, it calls out to that central IAM system and asks, "Hey, is this okay?" This gives an organization incredibly precise, fine-grained control. And it's really perfect for those complex corporate environments that have a ton of very specific rules. So we know who a user is. We've got that handled. But how do we actually decide what they can do? Let's zoom in on two really popular models for managing those authorization rules.
Okay, on the left, you've got the classic model, role-based access control, or RBAC. It's super straightforward. You're assigned a role like editor or viewer, and that role decides what you're allowed to do. Simple, predictable. But then, on the right, you have a much more dynamic, almost intelligent model, attribute-based access control, or ABAC. Instead of a fixed role, ABAC uses a flexible policy that evaluates a bunch of different attributes in real time, things like your department, the time of day, even your physical location, to decide if you get access.
So here's a good way to think about it. RBAC is like giving someone a key card that only works on certain doors based on their job title. It's easy to manage. ABAC, on the other hand, is more like a smart security system. It checks your key card, sure, but it also checks the time of day, whether you badged into the building, and maybe even if you're on the company Wi-Fi before it unlocks the door. It's incredibly flexible, and it's fast becoming the standard for modern zero-trust security. Wow, okay, we have covered a lot of ground. So let's just boil it all down to the absolute essentials you need to remember.
Here it is, your digital security checklist. Number 1. Authentication is proving who you are. Number 2, authorization is proving what you can do. Number 3, OIDC is the identity layer that adds the who on top of OAuth's what. And finally, remember that when you're designing systems, there's always a trade-off between having central control and being able to scale up.
So authentication and authorization, they're not just some techie jargon, right? They are the fundamental grammar of digital trust. They're the invisible gatekeepers that secure pretty much every single interaction you have online. Now that you can see them, the question is, where are you going to notice these guards at work next?